Hello, my name is Edward Cranford, and this is a pre-recorded presentation for the 2021 International Conference on Cognitive Modeling, for which I'll be discussing my research on modeling phishing susceptibility as decisions from experience. This research is a first step toward developing personalized anti-phishing training. Traditional anti-phishing training often involves making classification decisions on a sequence of emails and receiving feedback on accuracy. However, such training is non-personalized and does not account for experiential learning. In contrast, personalized training requires accurate models and predictions of individual behavior. As a first step toward personalized anti-phishing training, we propose an instance-based learning cognitive model that explains end-user phishing classification decisions as arising from experience. For example, vulnerability to phishing can be reflected by an end-user's personal interests and history of emails. An end-user that receives a new email from a seemingly known sender about topics of interest, recently discussed with a colleague, would be more likely to click on a phishing link due to its similarity to recent and frequently experienced safe emails. According to instance-based learning theory, decisions are made by generalizing across past instances. Our model is built in the ACTAR cognitive architecture and uses the blending mechanism to make aggregate retrievals from memory instead of retrieving a single instance. The decision retrieved is therefore influenced by the similarity of the features of the current email to features of past emails, and their recency and frequency in memory. IBL models are especially useful for personalized training because they can make accurate predictions of individual decisions from experience by incorporating a short history of their behavior. Combined with model tracing techniques, a model can adapt to an individual in real time. For phishing classification decisions, the features of the email include the semantics of the email. A novel approach was used to generate similarity values between semantic information, which allowed for an automated and adaptable model. We utilized the UMBC semantic similarity tool, which uses NLP techniques to generate semantic similarities between two texts of any length. This provides a rough approximation of the similarity between emails for typical end users that judge emails on their low-level semantics. The model was developed to perform a phishing classification task called the phishing training task, and we then demonstrated the model's generality by predicting end-user decisions in a different task that uses a different set of stimuli. The phishing training task was designed to assess frequency effects on training effectiveness. The PTT involves 3 phases, and participants are randomly assigned to one of 3 frequency conditions. The phases include a pre-test, training, and post-test. During the pre- and post-test, participants are presented 10 emails, 2 of which are phishing emails. And during the training phase, participants are presented 40 emails, and either 10, 20, or 30 are phishing emails depending on the assigned frequency condition. As shown in the receiver operating characteristic curves on the right, the model accurately predicts end-user phishing discriminability across phases and frequency conditions of the PTT. The model shows that the influence of frequency on post-test performance can be explained by the greater number of phishing emails in memory, which increases the probability of retrieving a phishing classification for future emails. Many interesting lessons were learned regarding parameter settings for the model, which I invite the viewer to read further about in our paper. To test the generality of the model, we tasked it to perform another phishing classification task called the phishing email suspicion test. The test was designed to examine an end-user's general susceptibility to phishing emails and involves 4 types of emails: real phishing and ham emails, and simulated phishing and ham emails. End users are presented with 40 of each type. However, instead of making a classification, end users give a rating of suspiciousness. As shown in the box plot on the right, the model accurately predicts the full range of human behavior, accounting for the mean and distribution of ratings for each email type. The model also accounts for both between-subject and within-subject variances, as shown in the scatter plots on the far right, that shows the correlations between real and simulated emails. In conclusion, the results of the test and those of the PTT highlight the model's ability to accurately predict human phishing susceptibility as well as its generalizability. The results show that phishing susceptibility can be modeled as decisions from experience, and importantly, relying on semantic similarities was useful for generating accurate predictions. NLP techniques were necessary to automate the generation of similarity values to allow for an adaptable cognitive model that can be used for personalized training purposes. However, in addition to relying on only semantics, future anti-phishing training should be geared toward training end users to detect high-level expert features such as link mismatches, appeals for urgency, or offers of rewards. This requires a model that can learn to detect such features in addition to the semantic features. Future research is therefore aimed at using the cognitive model to drive adaptive personalized anti-phishing training. A combination of instance-based learning models grounded in a cognitive architecture like ACTAR and model or knowledge tracing techniques can drive robust adaptive and personalized systems. As an end user interacts with a system such as their email client or a training system, an IBL model can observe the human and predict their susceptibility. This information can then be used to inform the system to provide personalized and adaptive training or interventions. The present research is a step towards this goal. Thank you very much for listening, and if you have any questions, please feel free to contact me at the email address below. Bye.